Once they were some of the most advanced structures and facilities on the planet, at the cutting edge of engineering design and construction. Today, they stand abandoned, contaminated, and sometimes deadly. In this episode, we aim for the stars and find out why unwanted battleship guns allow the United States to gain vital information about the borders of space.
I had absolutely no idea that space technology was anything but rockets that fired up, launched, and took off. You can get a great big gun and fire it up, pretty much do the same job.
We ask how the shattered remains of a secret Nazi base became the first on the path to a new world, with the development of the groundbreaking V2 rocket.
People forget the dark shadow that was cast over the genesis of the space program. It wasn't these ambitious goals of putting a man on the moon. It was military.
The V2 rocket was a remarkable piece of engineering. It just appeared out of nowhere, and then it struck with quite deadly accuracy.
We explore a forgotten structure deep in the Arizona desert to ask if it is the true home of America's space program.
They were doing something that no one in this country really had done. We did science for the sake of mankind out here.
And we reveal the bizarre link between a discarded oil drum and a Cold War struggle to survive in zero gravity.
This soon led to putting monkeys in the actual capsule and sending it up into space.
For centuries, mankind has been fascinated with the stars. Many civilizations have to make sense of what could be observed from Earth. But the truth, like the stars themselves, remains out of reach. It wasn't until the 20th century that technology advanced far enough to give us a chance to escape the grip of the Earth's gravity. One of the first space rocket launch projects of the 20th century was based at Peenemünde on the German island of Usedom. Hidden under the pine trees just yards from the Baltic Sea are mounds of shattered concrete and twisted steel. This is all that remains of what was once Nazi Germany's most secret military installation, Test Stand 7. Dr. Philipp Aumann is director of the Historical Technical Museum at Peenemünde today. He has explored the history of these mysterious ruins.
Peenemünde was the first professional rocket project in Germany and in the world. Exploring space was a key topic of this future ideology. The engineers working here, and they were nationalists, they were militarists, and they really had no problem serving Germany when they created this mighty, powerful weapon.
Governments were willing to fund this program because they wanted to have this military dominance in Europe. And so that flow of funding and the focused effort meant that rocket technology accelerated in a very short amount of time. I mean, just a few years to create something like the V2 was phenomenal.
In the early 20th century, the young engineer Wernher von Braun, with his expertise in rockets, was just what Germany needed. A man who could create long-range weapons.
Wernher von Braun was the leading rocket engineer here. He and his colleagues, they were engineers, and they had this technological challenge, and they wanted to solve it.
He was very enthusiastic about opening up the opportunities of rocketry for space exploration. I think even though that didn't play out during the war years, once he had moved to America, his work then became the foundations of the Apollo program, which took humans to the moon in the 1960s and 1970s.
Von Braun was given full backing by the German military. And when Hitler came to power, his rocket program shifted into top gear. In 1936, construction began at Peenemünde to create the first rocket testing range in the world. A special launch pad was constructed where rockets could be fired into the shallow waters of the Baltic and be recovered for analysis. This was Prüfungsstand 7, or Test Stand 7.
The whole sand wall is around here. It really closes the launching site, makes it an arena. This is the place where the rockets were launched exactly. They fired a little more than 300 rockets. I thought they were completely secret here, and nobody would find them.
In 1936, they had started their Peenemünde project to develop missiles of an entirely new type. And their first one was not a rocket. It was the buzz bomb, the V1. Its propulsion was by pulse jet engine. The Germans fired more than 7,000 of them, of which more than 2,000 reached London.
In October 1942, came the first successful launch of the rocket that would forever be associated with von Braun, the V2. Though it only reached an altitude of 52 miles, it was a signpost to the future. Standing 46 feet high and with a diameter of just over 5 feet, the V2 weighed 28,000 pounds and carried a ton of high explosive.
The V2 missile is in itself an extremely impressive weapon. And arguably, it's the start of putting man on the moon and rocket technology. But around that rocket, you've got the infrastructure and the facility that enabled the Germans to do what they did with it. We're talking about refueling the rocket. We're talking about producing that fuel in the first place. The logistics of getting everything that they needed, the monitoring systems in place, and getting that rocket actually firing.
But Hitler had no interest in space research. He wanted weapons of war. Orders went out for the V2s to start raining death on the Allies. But the new rocket was far from being an effective weapon.
The rockets never worked well. It was not a completely finished weapon system when it first was used. The whole history of testing and using it is a history of exploding and misfunctions.
The V2 was developed and being tested whilst the Germans were at war with the Allies. So, albeit that V2 rocket was not used for a purpose that we can celebrate, the engineering behind it was extremely thorough and very impressive.
In June 1944 came the historic launch from Test Stand 7, when a vertically launched V2 crossed into space. Traveling at 4 times the speed of sound, Von Braun's rockets were soon screaming down on defenseless civilians in London and Antwerp. But despite this powerfully destructive force, history tells us that it still wasn't enough to turn the war in the Nazi favor.
Hitler was obsessed with wonder weapons, and that's where all the money went. It was good for the US and the Allies at large because there weren't basic funding for infrastructure. There weren't enough tanks. People were riding bikes. It wasn't like state-of-the-art anything on the battlefield. And that's the irony.
In the end, as history shows, the Nazis were comprehensively defeated at the end of World War II, and many of its key V2 launch sites, like Test Stand 7, were destroyed. But the technology lived on when Nazi scientists, like von Braun, went to work for the Americans and took all his secret rocket development with him. As a result, in the heart of the US Army's White Sands testing area near Alamogordo, New Mexico, is another V2 launch site. This is Launch Complex 33. The 75 feet tall structure stands abandoned in the desert. Its girders weathered by decades of wind-blown sand. But how did White Sands become the place where America began its journey to the stars?
The genesis of the space program wasn't sort of these ambitious goals of putting a man on the moon. It was military. It was sending missiles straight up into space, not caring about where they go, but caring about how they come down and observing that so you can understand how you could use that information to attack your enemy. That was the start of the space program.
There is a group of visionaries, really, at the end of World War II, who have learned this lesson that technology is the key to future success. It's the key to survival in a nuclear world. And getting behind in any area of missile or nuclear technology may mean total defeat.
White Sands made its mark in history when the first nuclear bomb was tested here on July the 16th, 1945. But just 7 days earlier, the 3,000 square miles range had seen the establishment of what was then known as top secret White Sands Proving Ground. With the looming prospect of nuclear conflict with the Soviet Union, America needed to take the lead in missile technology. So far, its efforts had been completely outmatched by Germany's V2 rocket design. Could they catch up before it was too late? Darren Court is the White Sands Missile Range Museum director. He's studied the early days of this top-secret research.
Comparing the V2 to the first American rocket design, the V2 was a tremendous advance in the technology. What we had at the time, the WAC Corporal could put about a 35-pound payload, maybe 60, 70 miles into the atmosphere. The V2, we could push over 100 miles up with a 2,000-pound payload.
It was very secret at the time. We were certainly not going to let the Russians know what we knew about rockets and ballistic missiles.
As well as train cars full of rocket components, dozens of the German scientists who had run Germany's V2 program also arrived at White Sands.
Nazi Germany's prize secret, the deadly V2 rocket bomb, is assembled by U.S. engineers for testing. Rivaling the atom bomb in importance, the 46 feet of death and destruction is set in place by an ingenious elevating boom at White Sands Proving Ground near Las Cruces, New Mexico.
But the most important component of the V2 program to arrive was not a piece of rocket, it was Wernher von Braun, the father of the V2. But was the man behind Hitler's revenge weapon attacks the right man for the job?
Wernher von Braun was the head of the German rocket program. In other words, how do we develop missiles to fire at other cities around the globe? So when he comes over to the US and he's on their side, he jumpstarts their program like you wouldn't believe. It would have taken them decades to get where they got so quickly with his help. Without his help, they may never have caught up.
Von Braun, I don't think was really an ardent Nazi. I think that he created the V2 simply because he was a man that invented rockets.
America had everything that they needed to create a very successful rocket program. They had the rockets that they could learn from, their engineers could rebuild them, they could study them, analyze them, and they had the German rocket engineers who had the expertise already.
The experiences of the German V2 program made it obvious that the technology was far from perfect. As a result, the US Army constructed a massive blockhouse so that each launch could be monitored in safety. Covered with 27 feet of reinforced concrete, it was designed to withstand the explosion of a V2 100 yards away, or the impact of a V2 falling from 100 miles up.
The reason this building was built was because of the power of the V2. It carried roughly 19,000 pounds of fuels, which really were a high explosive charge. You combine the fuels. And we saw that on a couple of the V2 failures on the launch pad, where something set off one of the tanks and another tank went off, and there was a tremendous explosion. The 10-foot thick reinforced walls were built specifically to protect the people inside the building. The people in this room were critical to the success of the V2 launches. You had your guidance experts, your control, your combustion experts, the military commanders of the installation. You had really the brain trust of the V2 program would be in this room during launches.
5, 4, 3, 2, 1, 0. Rocket away.
At first, it seemed that the Army was right to plan for disaster. Launched in April 1946, America's first V2 only rose to an altitude of 3.5 miles before crashing in a huge fireball. Everything was riding on the next launch a few weeks later, and this time, the rocket climbed to an altitude of 71 miles before coming down 35 miles away.
Air Force pictures show the rocket in flight, and the flying camera automatically takes over. The huge projectile drops the Earth behind at the tremendous speed of 4,000 feet per second. The rotation of the rocket causes the planet to spin before the lens, and the camera photographs the Earth 65 miles straight down. The horizon, 720 miles away, and the curvature of the Earth are astonishingly apparent in this still picture from the film.
It marked the first successful launch of a large rocket on American soil and accelerated the United States into the space age.
I would like to have witnessed those early V2 launches from the White Sands base. For me, that was a time of great unknowns and huge excitement. I mean, I just can't imagine how it must have felt for engineers and scientists like myself to suddenly have access to space with these amazing rockets. There were so many unknowns. We wanted to be able to look at the stars and the planets unhindered by the Earth's atmosphere.
As the tests at Launch Complex 33 became more and more advanced, it was obvious that the basic systems in place were not up to the job. a brand new structure had to be brought in to set up the V2 before firing. Soon it would become a standard fixture at all rocket launch sites.
The original V2 flights, the rocket would be brought on the Mylar wagon, the original German transportation vehicle. It would be erected onto a firing table, and there were a couple of small ladders that were used to fuel it, get it ready, put the instrumentation in the top. The problem with that was, by 1947, a lot of the instrumentation was becoming more complex, took a lot more time to set up. So it was felt that something more substantial was needed. So the gantry crane was brought in from California in 1947. So it was on rails. You could bring it in, drop the platforms, do whatever you needed to do on the rocket, and then once you were ready to go, raise the platforms, bring the gantry crane away, and fire the rocket.
But White Sands not only pushed forward research into rocketry, it was also the first place on the planet to launch living creatures into the atmosphere. Live monkeys.
The testing of the V2 rockets for radiation in space evolved over time. It started with really simple things like maybe an ant or a firefly or a grain of corn, just to see what the impact would be of radiation in space. But this soon led to putting monkeys in the actual capsule and sending it up into space. Animal rights activists would have a field day, and rightfully so, today. But back then, nobody cared. Nobody knew. Problem was, the monkeys never survived because this was early days. The parachute technology to gracefully bring the craft down to Earth never worked. They died.
By the early 50s, White Sands had made incredible strides in space research and laid the groundwork for future progress. For all their success, the limits of the V2 had been reached. But the scientists and engineers at Launch Complex 33 had reason to be proud of their efforts.
Those early rocket launches from the White Sands base are somewhat overshadowed by the phenomenal success of programs like the Apollo mission. But those early projects were incredibly important.
There certainly was a push after the V2 program had ended to beat the Soviets into space. But I think it was sort of the newness of the whole thing. They were doing something that no one in this country really had done with these large liquid-fueled rockets. We did science for the sake of mankind out here, and I think that really drove what a lot of the science were pushing for.
The V2 rocket may have been a failure as a weapon of war, but as the first vehicle to reach space, it had been a triumph. While rocket designs were being refined at sites like White Sands, high in the White Mountains of California at Barcroft Research Station, more experiments with monkeys were taking place. Their focus was to see how these simian, living creatures would handle space travel.
Imagine the scene. It's the 1960s, the summer of love. How many Americans realize that monkeys are being taken up to a 14,000-foot high mountain and experimented with so that they could get an advantage about how to launch a space program? I think if they knew that, they actually would have been horrified.
Using animals, sadly, was a very valuable step towards getting humans into space. You simply couldn't avoid doing these kind of experiments. And of course, there were deaths along the way, and you wouldn't get away with that if it was humans, obviously. So this could have been the end of the space program.
In the early 1950s, Barcroft Station was a US Navy classified research facility. When the decision was made to close it down, the University of California stepped in to take over the site. With backing from NASA, Barcroft was converted to play a crucial role in the space program, using a unique colony of chimpanzees. University historian Daniel Pritchett has uncovered their forgotten story.
This was built in 1951, and they started gathering meteorological data at that point and started raising laboratory animals up here. Started studying the chimpanzees' physiology because they were planning to send chimps up into space before they sent humans. They needed to understand about chimp physiology and also develop monitoring devices so they could monitor the health and condition of the chimps while they were up in space.
The saga of Ham. The little chimp has been carefully selected, thoroughly examined, and patiently tutored to help mankind discover whether living creatures can survive travel in space.
You can get valuable data by just doing stuff on the ground with animals to simulate what you expect the space environment to be like. You will learn a lot more by controlled tests on the ground rather than just sending series and series of expensive rockets that maybe you don't recover the data back from.
If you want to test the effect of very high acceleration forces, you can do that on animals. If you want to test what harsh landings are like, you can do that on animals, and indeed they did. Even though there was knowledge about humans at high altitudes, what they didn't have at that point was knowledge about how the human body responded in a weightless environment. So those kind of experiments you can conduct on animals, and of course you do want to do that before you conduct them on humans.
This is an authentic relic from the early 60s, from the period when we were training chimps and macaques to go into outer space. This is a 55-gallon drum that's been fitted out with a little plexiglass seat, and it's a space capsule simulator. It's got insulation on the outside. It's fitted with catheters, which were surgically implanted in the animals, and this was for them to get accustomed to what they'd be doing in outer space.
With the chimpanzees sealed inside them, the tiny barrel capsules were suspended beneath a helicopter and flown to Barcroft Station. It was the beginning of an extended series of experiments to record their physical responses to stress and changing atmospheric pressure.
We're now on the ground floor of Barcroft Station. In the 60s, the ground floor had animal colonies. They had chimps and macaques here, and they studied the physiology of these animals, and they developed telemetry devices to monitor their conditions of their bodies and their health. Here, they could look at the effects of high elevation on the animals. They would train them to some extent, get them accustomed to sitting in little chairs, because when they put them in space capsules, they were confined.
The American approach, where you can train the animals to do things that are more similar to what humans might do in space, press buttons, pull levers, and so on. And it also means that you can gather data that helps you with the design of the cabin that you will ultimately use to put humans into space. Different countries sent up different animals, sometimes for obvious reasons, sometimes for less obvious reasons. For example, if you wanted to send animals up and you knew they weren't going to come back, you might send something like mice. But of course, you want to do experiments on larger animals too, and in Sputnik 2, the Soviets sent up the dog Laika. And they had a policy where they took dogs off the street. So the idea was that you would take animals that were used to living a harsh life, lack of food, lack of water, and therefore would be better adapted to the kind of experiments that they wanted to test.
can simulate temperature changes. You can put people in centrifuges who experience high Gs like in a rocket takeoff, but you can't do everything. We realize that even today. That's why we're still doing experiments at the International Space Station. Astronauts are guinea pigs in that regard. We're trying to understand how the human body is affected by weightless environment, how space radiation affects us. We are still finding our way with a lot of these things.
Chimpanzees were one thing, but what about human astronauts? From the very beginning of the V2 launch tests in New Mexico, scientists had been trying to find out whether manned space flight was possible.
This 30-foot-high apparatus provides data on man's reaction to blast-off buffeting and weightlessness and the effects of vertical acceleration. While the physical and psychological effects of prolonged vibration are studied, a breathing apparatus measures reaction of lungs and other organs.
In 1961, the Soviet Union's Yuri Gagarin became the first man in space when he orbited the Earth in Vostok 1. Immediately, the pressure was on the United States to rival the USSR's achievement. But it wasn't only in space that they were competitive. One of the US Army's most important research sites is the vast Yuma Proving Ground in Arizona. Standing alone in the desert wilderness is a single massive cannon. This is the record-breaking Harp supergun. Forgotten for decades, its incredible role in space research is only now being revealed.
I had absolutely no idea that space technology was anything but the cutting edge of rockets sent up into space. But apparently not. Apparently you can revert right back to technology that's centuries old. The gun. Just get a huge charge and fire it straight up.
Using guns to put something into orbit isn't a silly idea. In fact, it's quite a cheap and reliable method, potentially, to put something into orbit.
The gun was the crucial element in a series of tests carried out in the 1960s, called the High Altitude Research Project, or HARP. It was the brainchild of a ballistics expert named Gerald Bull, and its aim was to help make space flight a reality.
Dr. Gerald Bull, first and foremost, in my opinion, is a genius. Was a genius, is a genius. You look at what he was doing, very much the engineer, very much the scientist, always testing. When you began thinking of gun-launched technology for suborbital or orbital launches, there are a lot of people that made Jules Verne jokes about him. There were others that said, well, even if you could do that, it's worthless unless you have some kind of a telemetry package on it, transmitting data back to Earth. But Bull proved them wrong.
He had this idea that superguns were the way to get cheap access into space, and a huge amount was learned through that program.
The target for Bull's gun was the ionosphere. This layer of electrically charged air plays a crucial role in making ultra-long-range communications possible and can affect the flight of space vehicles leaving the Earth. At a time when rockets were still hugely expensive and extremely unreliable, Bull believed that his gun-fired sensors could deliver the information at a fraction of the cost.
If you want to know conditions up in space before you send a very expensive rocket, then you can fire cheap sensors up. Bam, 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 bam. Find out a bit about what is going on directly above where you're going to fire this big rocket. Then you're going to get some really valuable data, surely.
When the U.S. became involved in Gerald Bull's HARP gun project, it was a win-win. Sure, you're going to gather all this information about the upper atmosphere. Great. but you're also going to gain a strategic military advantage, because now you're going to learn about how you can launch missiles across the world at your enemy. So that's what they were really interested in.
Having the two choices of technology is important because these were really the early days of the space era. Technology was moving out of the Second World War and finding its use in a completely new frontier. And you don't necessarily know what's going to work. So it's much better to have the two approaches funded simultaneously, your rockets and your big guns.
The Harp gun standing in the Arizona desert reveals Bull's brilliance with big gun design. Yuma Proving Ground gunnery expert Wayne Childers has studied the history and construction of this record-breaking weapon.
The program picked up two 16-inch naval barrels. One was 69 feet long, and one was 50 foot long, approximately. And they're welded in the center and braced with the superstructure around it. Where the big bolts are right back here to the rear, that's where the two pieces were joined together and welded. They built this superstructure to stiffen, to keep them from coming apart, plus give it strength when you're up vertical. Because, you know, when you fire a gun like that, you might get a little whip and things like that, and you definitely don't want any tube droop or anything of that nature.
The mounting for Bull's gun had to be specially designed to allow it to fire at an angle of 85 degrees. The first gun to be built was set up at a site on the island of Barbados in 1963. Positioned just north of the equator, it meant projectiles could easily be launched into the atmosphere and recovered from the sea. Local historian Trevor Marshall knows all about reactions in Barbados to the giant gun, which still stands rusted and abandoned on the coast.
There were more than 2,000 firings of this gun in the period from 1962 onward into the 70s. That is quite a lot of sonic boom, and it was a heavy boom. Barbadians felt this boom from here up to almost the top of the island. The reverberations were terrible. Houses were shaken to the foundations, and quite a few cracks in houses were reported. Barbadians felt generally that this was all to the good of the island. It seemed as though it would project Barbados into the stratosphere of world prestige.
To get something up into space, apparently, it doesn't need to be rocket science. It can be so much simpler than that, as we see with the Harp gun. It's almost primitive technology that's just been ramped up to as big as it possibly can to fire a projectile 111 miles straight up.
As well as advantages of using a giant gun, there are drawbacks as well. So to get something to the speed that you need to get it high up in altitude, you have to accelerate it very fast. And your objects may not be able to withstand the forces, the G-forces that are experienced. And then there's also an issue of mass as well, because you can't launch particularly heavy things using this kind of technique. So you're limited to small objects.
Bull designed a revolutionary dart-shaped projectile to bring back information from the upper atmosphere. Called a martlet, it was encased in a World War II invention used with high-velocity anti-tank shells, the sabot.
The martlet was an aerodynamic shape. Think of it as a large dart with fins. So the idea of the sabot is to fill the void of the cylinder of the tube. In this case, they used plywood, each third called a pedal. And the gases would then push this thing out the barrel, and the pedals would fall away, and you would then have this very aerodynamic shape within the nose cone, a telemetry package, and in the aft end, the ability to eject certain materials depending on what your test was.
There is some detailed engineering going on here, but what I love about it is it's primitive technology with modern engineering applied to it to achieve something that's record-breaking, firing that projectile that high up.
Huge amounts of propellant were needed to blast the martlets high into the ionosphere. Every firing generated colossal forces within the Harp gun.
You can see the massive size of this breech and interrupted screw design that would allow it to lock in, and just the length of it just shows you the mass of this breech to be able to handle those charges and pressures that they're firing. They were looking at pressures PSI around 50,000, I think, with some of the testing.
You need to think about the materials, the size of the explosion through the propellant that you're going to use. You need to make sure the recoil's not going to just tear the gun apart, and that you've got a barrel that's long enough to project something that far up. There's a lot that goes into it, and there's a lot of thought and design that goes into achieving this. But at the heart of it, it's still very primitive engineering, and I love that.
After success in Barbados, a second Harp site was established at the US Army's Yuma Proving Ground. And it's there that Gerald Bull established a record that stands to this day. On the 18th of November 1966, the Arizona gun fired a martlet traveling at 7,000 feet per second, 111 miles into space. But today, it sits in the Arizona desert, its machinery oiled and ready, so that when the time comes, it can once again take aim at the stars. Today, Barcroft Station is still a center for research into life at high altitudes. But chimpanzee testing for the space program has long been abandoned. Rocket technology has now left the V2 far behind, and historic sites like Test Stand 7 and Launch Complex 33 are simply abandoned. Now, space exploration is aiming for new horizons.
The focus now on space is to reduce the cost. And we have such a wide-ranging use of space in our everyday lives as well, which is helping drive that. With SpaceX, their approach is to have reusable rockets, and that's how you bring the cost down.
The future of space exploration may well be dependent on billions of dollars worth of investment into technologies that we don't even know about yet. But it could also be partly dependent on much more simpler, maybe even call it primitive technologies, like the Harp gun. I'm not saying you're going to get a man on Mars by firing him out of a gun all the way up. That's not going to happen. But if we're talking about getting payloads and objects into low Earth orbit, which could then be assembled as part of a project to then go off further and take us places and be able to analyze space more than we ever have done before. And it just makes me smile, the thought of that you could have this combination of technologies and of engineering eras that come together to give us something that is, well, at the moment, out of this world.